Welcome back everyone. Now we are going to learn about the junction devices, and in the junction devices we are going to learn the three most important things. First one is the photodiode, second one is LED, which is light emitting diode, and then after we are going to learn about the solar cells. So let's start with the first one, which is our photodiode. So I'm using the short format. You can write the full form, that doesn't matter actually. It saves just the time, that's why I'm using the short forms. So what is the photodiode? Photodiode means here is our sun. Okay, not my sun, it's the sun. The sun. Okay, now when it falls on our PN junction, what actually happens? Light falls on the surface. Actually, I love to consider the N side on the uppermost layer and P side on the downmost layer. I will tell you just in a moment why. So when it falls, electrons at the surface electrons get excited and comes out. If we somehow have a wire, we have electricity. This is the negative one, this is the positive one. We can clearly have that because of the sandwiching layer that I have not shown here, but as you can imagine, the electrons are redistributing themselves in the depletion region. So this is all about it. That's it. That is the photodiode. So what else we can have here? Well, very interesting thing, which is the intensity of light is directly proportional to the current we get. Intensity is proportional to current. So intensity is important here. If you do not have the intensity of light, you do not have current. If you have more intensity, you have more current. So what is the intensity? Intensity is the photons that comes from the sun. Like when you stand in the sun and take the sun bath, what actually happens? A feel of great relief in the winter season. Actually it happens. So why this happens? We get the photons and vitamin D, so it's good for health too. So we get this and we have this thing to be done. So this is all about the photodiode that we have learned here. So this is the photodiode. Photodiode means, now the name is making sense. I hope that photons are falling on the surface and that surface excites the electron. When electron get excited and we make a system that it can travel in the wire, we get the current. That simply means we get the voltage there, and we can use that to measure the intensity of the light. We can use and make our devices working. It sometimes rely on the lower left part or lower right part of the calculators. If you have an old calculator one or scientific calculator, you can might have seen the black patches. That is solar cell. Yes, I know you will going to say that, but that can also be called as photodiode. So this is all about it. Now in the next one we are going to explore the next one, which is LED, the most famous one. As you have learned about the photodiodes in this one, that the light falls, electron get excited and the intensity is proportional to the current. Now it's the time to learn about the LED. So what is the full form of the LED? First of all, the full form is light emitting diode. Light emitting diode. So yes, as you have seen, it is a diode that emits the light, and that's it. Yes, absolutely, that's all it. So why I was very much excited? Well, just to keep you busy with the learning part. That's intentional, right? My tricky one. When you become the teacher, you will know that. Okay, so this is the diode. Diode means a simply bulb or a crystal inside, and when it hits by the electricity or the electrons get excited in the crystals, it produces the photons, and that photons are actually nothing but the frequency, and that frequency is the color, and that color tells us about the color of the light. So this is actually the principle of the light emitting diode. You might have seen so many diodes, as LEDs are quite famous these days, like you have seen in your bulb. If you look closely, if you have an LED bulb, you will see that there are so many of the small bulbs inside, and that get into surface and reflect back and forth, back and forth, back and forth, and finally produces a overall glow in your room because of that light. So what a teeny tiny thing actually do? There is a crystal inside, sometimes the filament too, and that crystal get hits millions and billions times by the current. Current is what? Something like electrons is passing from hitting this one, so it gets heated up, and that crystal's electron get excites, and that excitement brings out the frequency, and that frequency is the photons in the form of the visible range frequency, and that visible range of frequency tells us about the color, and mostly I prefer the yellow color and white color. Well, let me tell you something interesting that I have tried once. Well, the topic is over actually. If you wish to leave this and start the next one, don't do that. I'm going to tell you something very exciting over. Okay, so when I was young, I was thinking that why is not there any black bulb that when I switch on, it darks the room? Do you think it's possible? Let me know in your comments about the solar cells. As we have seen, the photodiodes and the light emitting diodes. So it's not the rocket science, right? But let's learn about the solar cells that are quite obvious ones. So what are the solar cells? Well, as the name clarifies, there is a sun, and the sun then falls on the sandwich layer of P and P. Well, you can take it in any combination, and one question is left, that why I am always keeping the N on the upper side. I'm going to tell you that in a while. So it is our sun. Well, I kept it so close. If it is so close, I will going to die. Yes, you are also going to die because you are watching me. Okay, so what about the next one? Let's get a little bit not serious, be jokey, right? So it's our sun, and when its photons falls on this one, the electron again get excited, and that excited electron is stored, as the word says, is it stores the energy. It stores the energy, and we get the point. We have a storage here. So when we have a storage here, we can store that electricity and we can use it anywhere we want. Well, so what is here? Here is the battery. Yes. So here is something that I want to teach you. So I'm going to teach you a different scenario. So we have two questions here. First, why I am always keeping the N side up, and the second one, is there any source that we require in solar cells, in LED, and in photodiodes? So we are going to explore that in the next one. Stick with me. Take care. God bless.